In this problem, we're going to examine a logarithmic function. We're going to use the function f of x equals 1 minus log base 5 of x minus 2 to find the domain of the function, graph the function. From the graph, determine the range and any asymptotes. Find the inverse function. Use the inverse to find the range of the function. And then lastly, graph the inverse. I'm going to start by finding the domain of our function. See, the domain will be the set of all real numbers such that x minus 2 is greater than 0. Look at the argument for our logarithm. We need this to be a positive number, so we need x minus 2 to be greater than 0, or x is greater than 2. So the domain for our function is the set of values for x that are greater than 2, or in interval notation, 2 to infinity. In part B, we're asked to graph our function. We're going to do that by using transformations. We'll note that our base function is y equals log base 5 of x. And we'll do some transformation steps. Our steps will be a shift right of 2 units. Then we reflect about the x-axis. And then lastly, we'll shift up 1 unit. So we see these 3 transformations by looking at our function. We'll go right 2 units, because we have x minus 2. We reflect about the x-axis, the negative outside of the log. And then we go up 1 unit because of the plus 1 that we have out in front here. So we'll start by graphing our base function, y equals log base 5 of x. We know that this base function will have a vertical asymptote at x equal to 0. And if we plot a couple of points to give us the shape of our graph, we pick the point 1, or the value 1 for x. Log base 5 of 1 is 0. So we'll have the point 1 comma 0. If we let x equal 5, log base 5 of 5 is 1. So we'll have the point 5 comma 1. If we go ahead and connect those, and then as we approach our vertical asymptote as we go towards the left, we have a rough graph of our base function, log base 5 of x. And we're going to apply our transformations to the 2 points that we plotted and our vertical asymptote. We'll start with our point 1 comma 0. We'll go right 2 units. It would be at 3 comma 0. Reflecting about the x-axis. We're on the x-axis, so that doesn't change where we are. Then we go up 1 unit. That puts us at the point 3 comma 1. The point 5 1, we go right 2 units. We're at 7 1. Reflect about the x-axis, puts us down at 7 negative 1. And then we go up 1 unit. So we have the point 7 comma 0. We had a vertical asymptote of x equal to 0. If we go right 2 units, we're at x equal to 2. Reflecting about the x-axis doesn't affect the vertical asymptote. Neither does shifting up 1 unit. So for our function, we have a vertical asymptote, x equal to positive 2. We're going to go ahead and connect our 2 points, extend our graph. And as we go towards the left again, we approach our vertical asymptote. So here we have the graph of f of x. We were asked to determine the range. By looking at the graph, we can see that the range is going to be all real numbers. So we'll say the range is the interval negative infinity to infinity. And any asymptotes, we see that we only have the one vertical asymptote at x equal to 2. Now that we looked at the graph of our logarithmic function, we'll shift our attention to finding the inverse of the function. We were given the function f of x equals 1 minus log base 5 of x minus 2. To find the inverse, we'll first write y equals 1 minus log base 5 of x minus 2. We'll interchange our variables and write x is equal to 1 minus log base 5 of y minus 2. And this will implicitly define the inverse function. Our goal is to now solve for y to explicitly define it. We'll start by subtracting 1 from both sides. So x minus 1 equals negative log base 5 of y minus 2. Multiply both sides by negative 1. We get 1 minus x on the left equals log base 5 of y minus 2. And here we have a logarithmic form. If we change to an exponential form, we can write 5 to the 1 minus x is equal to y minus 2. And then solving for y, get 5 to the 1 minus x plus 2 is equal to y, which is our inverse function. And we should verify that f of f inverse of x is equal to x, and f inverse of f of x is also equal to x. And we'll leave that check up to you. For part E, we want to use the inverse function to find the range of our original function, f of x. Since the domain of the inverse is the same as the range of the function, if we can find the domain of our inverse function, that's all we need to do to find the range of our function f. Looking at our inverse, we see we have an exponential function. The domain of this exponential function is all real numbers, so the range of f is all real numbers. And in interval notation, we'll write that as the interval negative infinity to infinity. The last thing we need to do is graph our inverse function. We can do that several ways. We could plot points, we could use transformations, or we could use our the original function f. We're going to go ahead and use our original function f to get our graph. And here we have the graph of the inverse. We're going to look at how this graph was obtained from the function f. Earlier, when we graphed f, we plotted the points 3, 1 and 7, 0, as well as the vertical asymptote x equal to 2. To graph the inverse, we interchange the x and y coordinates. So for our inverse function, f inverse, we would be plotting the points 1, 3, 0, 7, and we would have a horizontal asymptote of y equal to 2. So if we look at our graph, we get the point 1, 3, and we'll have the point 0, 7, and we have our horizontal asymptote of y equal to negative 2. We connect those points with a smooth curve and approach our horizontal asymptote. We have the graph of our inverse function.